Hello and welcome to Bonhill Geography. In today's video, we'll be looking at flood management and the causes of flooding in Pickering. Before we begin, let's first look at the characteristics of Pickering's basin. Now, Pickering lies within the Pickering Beck catchment area. This is an elongated drainage basin with steep valley sides. This shape means that rainwater concentrates quickly into the river, meaning discharge increases with short lag times and high flood peaks. The area also has numerous tributaries feeding into the main channel. This accelerates water flow during storms. This, combined with impermeable geology in multiple places, makes the basin highly responsive to heavy rainfall, meaning the peak discharge significantly increases after an intense rainfall event. Let's now have a look at how people have affected flood risk. People have drained the moors and upland areas in the Pickering Beck catchment. As the previous slide indicated, this is primarily for agriculture. Now, this means that drainage channels directly feed into the river, hence meaning flow rates downstream will increase. Parts of the moors have also been burnt to reduce vegetation, particularly for heather, for example, which in turn increases soil erosion and decreases soil permeability. Now, soil erosion is actually quite important because all of that soil ends up downstream, which means that the river bed decreases in storage capacity. As a result, meaning flood storage decreases and flood risk increases. In the east of the catchment, significant deforestation has taken place. Now, as we know, trees are excellent at stopping water and slowing it down, of which this process we call interception. However, they also increase soil permeability and increase the rate of infiltration, meaning more through flow would take place. Without trees, the amount of surface runoff increases. As we know, surface runoff is the fastest flow to the river, meaning peak discharge downstream would increase. Now, some amount of urban development has taken place. That being said, this is still relatively minimal. However, despite being minimal, impermeable surfaces have increased, so we will still mention this. It's important to note the image in the background is not showing Pickering, but I've just used it as a representation. As we already know, urban areas are relatively impermeable surfaces, meaning that surface runoff will increase and infiltration will decrease, again leading to higher peak discharge in surrounding areas. Let's now look into the history of flooding in Pickering. In 2007, intense and prolonged rainfall overwhelmed the catchment. Over 85 homes were damaged, costing more than £7 million. Now, roads were closed, businesses were disrupted, and residents faced months of recovery. While you're not expected to remember these specific facts for your A-level course, it's still good to be able to remember some to set the scene for your 20-mark question. Now, despite the history of flooding, some good efforts were made. In partnership with some universities, DEFRA and the UK Forestry Commission, they managed to slow the flow downstream. Now, the ambition of this scheme was to work with nature, one of which of these schemes was 129 leaky dams. Here's a good example of one behind you. So these were built in streams, which essentially are going to slow down water and encourage infiltration, reducing peak discharge and increasing lag time. They will also try to store water further back in the upper course, meaning there's less water downstream. So as a result, they almost act like a small weir. They are also very cheap to put in with relatively little cost, however they do require maintenance. Over 40,000 trees were planted in the east of the catchment, in the previous area where deforestation had taken place. Now, the ambition for this was to plant them in areas where they would make the most impact, so there was as little impact on farmers as possible. Most of the zones chosen for this were riparian zones, meaning areas either side of the river. Now, trees, as we know, are going to boost interception, they're going to boost short-term storage and hence evapotranspiration, which is going to slow down runoff, improve soil water storage and delay those flood peaks. So our lag time will increase again. Now, a large earth bund was also constructed, which stores up to 120,000 cubic meters of water. Now, a culvert, an example of which you see behind, will gradually release that water downstream. Now, I've not included the image from Pickering because it's not mine to show. However, I will change this in the future if I get the chance to visit. But essentially, the culvert limits the flow downstream. Imagine that pipe was full, but there's still lots of water behind it. It means that only that maximum flow rate can be released at one time. Again, this is going to result in our lag time significantly increasing. Despite that, this has come under some criticism, stating that for a concrete culvert surrounded by a hard engineering scheme, because that's what it is, this is not really working with nature. Now, the last most significant action was they blocked the drainage channels that they had previously installed. And you can see a really good visualization here of how that helps to retain that water in moorland environments. As a result, it means that there's less water downstream, and instead of the moors becoming a source for water, they are now almost like a sink or long-term store, with water trickling out rather than flowing away. Despite that, this has caused again a little bit of controversy, where these areas were primarily used for farmers, particularly in pastoral agriculture. With these areas now wetter, their profits will significantly decrease, and hence as a result, there's less kind of economic sustainability for them in these areas in comparison to the past. So together, these measures help to cut flood risk from a 25% chance in a year to less than 4%, reducing total peak flow rates by up to 20%. That being said again, it's argued that this is not due to the natural defences that were put into place, but actually due to the culvert, of which is mainly out of the price range for the majority of other rural towns in similar situations. On both this and the next slide, you will find two summaries of all of the information I have discussed. For people that are in my sixth form, you will have lots of information in your books already. I'll pause these at about 20 seconds each. Okay, so here's an example question. We've only been asked one so far about a river flooding example. Let's read through it together and make sure we understand how you would answer it. So with reference to a river catchment that you have studied, Pickering in this case, assess the potential factors which can impact upon the flood hydrograph. And so here we'd have to be referring to the causes of flooding, but you could also counteract them with the solutions to flooding, because we have looked at both the causes of flooding in the first place in comparison to how people slowed that flow downstream. So I would recommend in total having around 3 P-seal paragraphs followed by a conclusion. You may also choose to write a short introduction outlining what has caused flooding in the past. If you'd like further clarification on this, please feel free to drop me a message on my latest post. Otherwise, I'll catch you next time. See you in the next video. Please comment on my post to tell me what you would like me to explore next.